Okay, our last lecture, last module of the PIC. The module is called Capture, and what it does is it uses timer 0 or timer 3, or both of them together, to capture rising or falling edges that occur on CCP1 or CCP2. And it stores that time so that we can read it, compare it, and do calculations for things. It is on the same pin that uses PWM, and partly that's because this pin is called the Capture, Compare, and PWM pin. We won't be talking about the compare function. So today we're going to talk about capturing. Okay, so what do we need? Well, the capture of functions are fairly straightforward. There's one for each pin, Open Capture 1 or Open Capture 2. We have to configure it appropriately. And we also have to tell the capture module which timer we're going to use. There's also a flag that is used to tell when an event has occurred. So we typically wait for the event to occur, and then we read the value. Again, n is 1 or 2. In Open Capture N, the settings are the capture interrupt on or off. We're always going to have off. We don't use interrupts. And we can capture every falling edge, or every rising edge, or every 4 rising edges, or every 16 rising edges. I don't know why you would use these. Probably there's some use for it somewhere. I don't know. Not particularly worried about it. We're usually going to be looking for falling edges or rising edges. The timer source is we either use timer 3, which will be the timer for both pins, so we're using the same timer for both pins. Or you can use timer 1 for capture on pin 1 and timer 3 for capture on pin 2. That gives us some independent timing. Or we can use timer 1 as the source for both. First thing, you have to configure the timers, right, if you want to use using open timer 1 or 3. And when we capture times, it's possible that the timer has run over, so we should always be checking these flags as necessary. Here's the sample code. Here's me configuring the timer 3. Interrupt off. There's a funny line there. Should be an underscore. We're using 16 bits of information, so an integer for the read timer. And we're using internal source and these two. Okay? Make sure you have all of these in here, or you can have some odd things happen. Here we're setting it to use timer 3 as the source for both CCP1 and CCP2, but I'm only going to use capture 1. I'm not using capture 2. So in a while loop, if you have a repetitive signal, you would rate timer 3 as 0, reset the flag so it doesn't overflow yet, and then you tell what you want. Here it's every rising edge, and the interrupt is off. The flag is set to 0, and we wait for the event to occur. When we find that event, when this finishes, that event has occurred, we measure the time. Okay, so here it would be a rise time. And then I can refigure the capture to fall the next falling edge. Same sort of stuff here. So remember when we timed how long a button was pressed for? And we used the timer and the button software we wrote? This would be a lot more efficient to do. So let's look at our program. Here's our program. Exactly like I said, I've created some variables to hold the numbers. I want to output, so a message for the output. here I'm using timer 1, and all the settings for timer 1, and I'm using timer 1 and for CCP3, 1, T3 for CCP2, okay, but I could have used this guy. Doesn't really matter. Now, to give me something to measure, I'm going to make the CCP2 or PWM2 output a signal, and I'm going to measure that guy. Typically it would be some other device that would be measuring, but this is kind of convenient that we have a nice square wave that we can measure. So here in the while loop, I've got rate timer 0, flag set to 0, okay? And I'm filing the first rise, the first fall, second rise, second fall. Okay? I also read what the flag is saying, and then a delay, because I want some time for printing. I don't want it to overcrowd the screen too rapidly. And here I print it all out. Printing is a very slow operation. You only want to print out at the end of all the captures you want to make. So you might have your read captures read values into an array. That might be a good thing to do. And then print out the array of results at the end. Let's load this on to my chip and then see what our output is in Betty. Okay, here we go. So I've wired up CCP1 and CCP2 together, so it's reading that signal. I'm holding this so it doesn't change. If you look at the first rise at 692, the first fall is exactly 200 instruction cycles later. That's what we programmed. The next rise is 800 bigger than the first rise. The period's 800. And then the second fall is 200 after that. So this is working all the way through just perfectly, just what we want. Letting it back on. So it works great. Now, when you're doing timing, you have to be very careful. This statement, all these statements take time, right? And then it waits for the flag, okay? And then you have to read the flag, which also takes time. If the time between events is too small, you could lose the result. I'm going to show you what I mean. Up here, this is set for 200. I'm going to change that to 100. I'm going to reload and see if I can measure that many apart. Okay. Come on, come on, come on. Fun stuff, how long it's taking. Okay, so if you build this project on your own, make sure that you've connected CCP1 to CCP2 by a wire. Jumper them together. Okay, now I'm going to load it. Okay. And let's go and see what we have. So this is now the difference between the two. Between R1 and F1 is only 100. Did that fine. Perfect. Go back to the function. I'm going to make that 50. See if that'll work for me. It'd be nice if this compiled a little faster. Any second now. Ah, So let's load it on and see what's going on here. Okay, 33, 83, 50 a part, so that's fine. We can do 50. Let's make it even smaller. Right. Let's make it 25. I'm halving each time. It's actually 25 times 4. Well, right. Looking at that code, 25. Yeah, no, 25 by the way I've scaled it. Function, we're waiting 5. Okay, that worked. Let's load it. See what happens in PuTTY. Okay, uh-oh. Now there's a problem. The first one is 692, but then 1517. That's not 50 a part. It's missed that first fall, and it's gone up to the next fall, which would be 850-ish or something, 825, and that's what it seems to be doing. Okay, so it missed that first edge. We have to be careful on things like that. Okay, so anything smaller than 50 is going to give you bad results. That's how close the two events can be together. You can do things to work around that, but you're always going to have some time that you can't have very close effects. Let me end here. That's it, guys. This is the last video lecture. Hooray!